This is the first lectures of engineering materials and material science fundamental. We'll see different types of materials, some of its properties and examples. So basically engineering materials are divided into four categories. These four categories are metals and its alloys, ceramics, composites and polymers. So first we'll see what are metals and its alloys. So metals are generally found in the left side of the periodic table. And they are elements that are found naturally and has a higher electrical thermal conductivity. They are shiny, they are hard, they are tough. The alloys. Alloys are homogeneous mixtures of two or more metals at an atomic and molecular level. So they are fundamentally mixture of metals. The examples of metal we all know: iron, aluminum, copper, gold, silver. And the alloys are bronze, brass, some alloys of gold, copper is also there. There are many alloys which are used for fabrication industries like alloy steel. The second category is ceramics. This is particularly important for different examinations. And ceramics are compounds of metallic and non-metallic elements. In metals, they are pure metals. There are no non-metallic compounds involved. But in ceramics, there are non-metallic compounds are also there. They are poor conductive of heat, and also electrical properties are also poor. Some examples are metal oxide like Fe2O3, iron carbides like cementite Fe3C. Metal nitrides are also ceramics. They have very high strength, and they are also used for insulation because of its low thermal conductivity. The third category is composites, and this is very important for interviews which are highly technical. They ask basic questions with the difference between alloys and composites. So this is an homogeneous composition, alloys. But on the other side, composites are not homogeneous compositions. They are heterogeneous or maybe homogeneous, and mostly it is heterogeneous composition, and it is like a combination of two or more chemically distinct and insoluble phases. And properties are very superior than the basic constitutions which are insoluble phases. And it has a metric phase, which is this blue color lines, and it has a dispersed phase which is randomly dispersed inside the metric phase, and both these mixture forms a composite. And these properties of this composite is superior than the base elements of the metric phase and dispersed phase. And the examples are cement, concrete, which is used for building houses and buildings. The carbon fiber reinforced plastic, which are used in shield of rockets, and also shields of the re-entry element capsule which comes to the earth after the rockets launched it into the space. When there is a lot of friction between the air and the capsule, then there is a carbon fiber reinforced plastic on that side where the heat is generated, because it can take a lot of heat. It can take a lot of heat in terms like it has a high resistance to heat, and it maintains its strength at high temperatures. The glass fiber reinforced plastics, which are also used in piping industries like oil and gas and chemicals. The last category is polymer. The polymers are organic compounds of hydrogen and nitrogen, and long chain polymers are there with hydrogen carbon chain. It has a low strength, low density, resistance to electrical and thermal conductivity, and it has a very lightweight as compared to metals. Two categories are thermoplastics and thermosets. On heating and cooling, it can be recycled. Thermoplastics can be recycled, but once the thermoset plastics are set, we cannot recycle it by heating. Examples are PVC, nylon, polyethylene. These are the examples of thermoplastics. Some of the examples of thermosets are bakelite, which are used to manufacture switchboards. One of the important categories of materials is also there. In material science, we categorize it as crystalline and amorphous, which is basically non-crystallines. So in crystalline materials, it follows a crystal structure, and the crystal structure, one crystal has a unit cells, and arrangements of unit cells makes one crystal. So the materials which follow such structure in an organized manner are called crystallines. On the other hand, on amorphous non-crystalline structures, which has a random orientations of atoms and no defined positions of atoms inside the materials, they are called amorphous materials. The crystalline material has a very high density and has a defined melting point. At one particular point it melts, and amorphous materials has very low density as compared to crystalline materials, and it melts as a range of temperature. It starts from one temperature to starts melting, and at a particular range it continues to melt. The examples of crystalline materials are alloys of metals. Pure metals are also crystallines, and amorphous materials are plastics and glass. So this is a video which categorizes the material in very basic terms and gives you the idea of all the categories which are asked in some exams, and also it is necessary to understand the basics of material science. Thank you for watching this video, and subscribe to have more such short videos for technical subjects.